Добрый день, уважаемые участники. Меня зовут Стручков Нергун. Я сейчас являюсь временно исполняющим обязанности программного директора. Рады мы вас приветствовать на нашей площадке. Мы открыты уже, буквально скоро 3 года у нас будет. И хотелось бы рассказать именно вкратце, как вы можете воспользоваться точкой кипения. Вам главное создать свой профиль на лидер ID, и вам откроются все 119 точек кипения по всей России совершенно бесплатно. Вот. Так что добро пожаловать. Вы можете проводить разного рода мероприятия. Главное, пишите нам, звоните, и мы поможем вам организовать ваше мероприятие. Спасибо.
Dear friends, my name is Dr. Vasily Pavlov. I'm the principal of the Sakha Junior Science Academy, and we have just our typical and normal webinar, which is we usually held every month, usually on all different topics, and it will be broadcast directly to our YouTube channel. And you will have opportunity again to see it if you on your time that will be most convenient for you. And today, the topic of our talk is the climate and the climate changes and the studies related to the climate and the global changes that connected with the climatic changes that happening now in our planet. And in fact, Yakutia, as you know, is the place which greatly affected and is going to be affected by all these climatic changes, because these few months we've been suffering an extreme heat. And every year, this occurrence is happening all the time. Our climate is changing rapidly. And because the Yakutia is actually a permafrost area, and the effect of the global climate change is far more prominent for the Yakutian people and the Yakutia itself, because we're actually living on a very precarious land, which is in fact called the land of the permafrost, and every changes that affect our soil and every structure that built on it. And today, I'm very happy that we have a very distinguished panel of guests. First of all, I would like to introduce Professor Tрофим Максимов, who is a very prominent climatologist, a prominent scientist, and he's actually representing here the Russian Academy of Sciences. And in fact, he's one of the leaders of the Federal Research Center in Yakutia of the Russian Academy of Sciences, which is in fact, in a couple of years' time, will be celebrating 300 years of research that was done in Yakutia, which is a very much the start of all the scientific research in this part of the world. And also, I would like to introduce our guest. She's our compatriot and a lady of very great prominence, who actually at the moment is a doctor of sciences from the Warsaw University, from the Department of Artes Liberales. Her name is Kunnay, which is a very Yakutian name, Kunnay Rivolievna Takasaeva. So it's a very, very unique, the name and the family and everything. So in fact, yes, and in fact, our very precious guest today have a very beautiful project that she's been doing for a couple of years with the children from the Arctic regions of Yakutia. And she produced a beautiful book. And today she's going to tell about her project a little bit, and then she will have another engagement. So I'm going to give her the floor first, please.
Thank you. My pleasure. And I want to say hi to everyone who connect with us here. I want to present my book. This book, we organized project 3 years ago with Oymekon district, which is coldest place in the earth, habited place. And in Oymekon school, we invite children who want drawing. Also, this is comic book and coloring book about Chishan and global climate changing. Right now, this is very actual problem, and this I hope this comic book will help to ecological education, not just children from Sakha Republic. Also for, this is international project. And we printed this book in Warsaw University. And I want to say, and I want said thank you to every children who drawing in this book. Okay, I want to show some pictures. Подержите, микрофон подержи, пожалуйста. Okay, here is this comics and children drawing this history, very interesting history about our Chishan, which is our Sakha brand and cold. He is like a lord of the cold, live in Oymyakon. And children, for example, this picture drawing Anna Karyakina, 15 years, she's from Usniera. These pictures, Natalia Shkulova, 15 years old. Look how she described this global climate change. And this comics is, all comics is very interesting and beautiful, and I'm very happy how children create this. Next step, our project, I hope we will make computer games with Chishan and about this history. Okay, enjoy this book. Thank you.
Ребята, пожалуйста, делайте без всякого 3 да, просто откройте. Это просто обычная у него как-то он включает, там у него появляется экран и написано, что только через 3 это будет включаться. Наша система нет. Сейчас это работает. Здесь almost open. That's not a DPM or that's what they say. Там у вас написана дата, почему-то 19, а должно быть 18. Может быть, дата no, there's only one meeting at the whole day. Потому что у него там написано
Okay, okay, very good, excellent. So thank you very much. Thank you very much, Quinday. Thank you. Да. Обращайтесь. Okay. Okay. Thank you very much. So now, can we open up the Zoom link with Dr. Patrick Lam of Hong Kong? Okay, откройте, пожалуйста. Hi, Patrick.
Hi. Haven't seen you for a long time.
That's very nice. You know, it's lovely to see you. We're extremely happy. May I introduce the people who are actually with me? We had a lady from Warsaw University. She just left because she presented her beautiful book that she's done with the children of Oymyakon, which is the very cold place in Yakutia, the coldest part of Yakutia itself. And today we have a very distinguished climatologist scientist, Professor Troфим Максимов, who is actually does a very interesting research work here on the changes of climate, etc. And I have also my nephew. Can you see Meir? Meir is here. Yes, hello.
Hello.
And so I would like to introduce Dr. Patrick Lam. He's a professor and reader for the several universities in Hong Kong on the different topics, especially connected with the gifted education. And also he is actually an author of couple of very interesting projects that connected with the ecological studies and the ecological education for the which is extremely popular for the children of Hong Kong and also for the wider China. And I would like to ask our very distinguished friend, colleague, Professor Patrick Lam, please can you give your speech on the topic of studies that connected with the water and the climate, etc., and all this assessment that you've been doing for several years. Thank you very much. So you can give him the opportunity to open up the presentation, okay?
Yes. So can you see the PowerPoint that I'm going to present? Okay, good afternoon. I'm Patrick, and is a professor in Hong Kong University, Baptist University, and I'm also teaching in Chinese University. They are all my part-time work, and my full-time work is a school principal. And my school is called Lutheran Academy, and it's the only school, government school in Hong Kong that offers international curriculum, that is IB, International Baccalaureate. I'm currently the chief principal of the both primary and secondary school. And also my strong interest is also in ecology, because I was a geographer by training, and in my past 30 years, I worked, closely with young people, and especially 10 years ago, I brought students to Antarctica, to Arctic, for scientific investigation, including the topic of climate change. And also I've been to Yakutsk for 6 times. And so we also have got some exchange between Hong Kong and Yakutia. So that's why it is my greatest honor to share here today. And I was given about half an hour to share about what we are doing here. And my topic is ecological investigation, field study of water quality and environmental impact analysis research. And this particular research is in collaboration with Hong Kong University and Chinese University. So that's why there are 2 professors from these 2 distinguished universities working closely with our school. And especially, we try to put the research, into the secondary school, the high school students, basically year 11. Okay, and we are very much interested in water quality in terms of the ecology, because in Hong Kong we are an island. We are also a peninsula attached with mainland China. So we are near the just the shore in the South China Sea. So that's why in Hong Kong when we are talking about ecology, and then we have to consider marine ecology as well. And in Hong Kong, we also face the problem of the marine ecology, and there are many reasons. One of the reasons would be the human activities, especially the industrial development in mainland China. They have got a lot of sewage, and also we face the problem of climate change, because we haven't got much scientific investigation, but we discovered that we have less and less fish in Hong Kong. For example, in the past, we have a lot of fish, different species like granularia or many others. But now we relied on import. Okay, so one of the reasons these scientists find out is the ocean acidification caused by the climate change. So this diagram illustrates, it visualizes the situation. If we have got one, in normal situation, we have got the less carbon content, the temperature is okay. We have got fish and coral, okay? But if the temperature increases by 2 degrees Celsius and we have got more carbon getting into the water, and then the coral, is dying, okay? And then because in the food web or food chain, they're the source of food for the fish. So that's why, there will be less and less fish. Of course, if the water temperature further increase and more carbon, is found in the water content, and also you cannot find anything. So this is the gradual change, of the water quality in Hong Kong over the past 20, 30 years. Now, this is the conceptual understanding, but is it really true? And in fact, we have got some government monitoring of the water quality, but they haven't got much association, with climate change. So that's why when we discuss with universities and would like to understand this situation in a better way, and then we come up with a research study. It's a longitudinal research. That means, it's not just a snapshot this year. We'll do it next year and the years after. Okay, so we'll do it every year. And this is done by year 11, the high school students, okay? And we pick 4 areas for our investigation. They are the 4 corners of Hong Kong, okay? As you know, the upper part is attached with China, and the southern part is facing the Pacific Ocean or South China Sea. So that's why these 4 corners are very different, and this can help us to have a very good picture about the water quality, whether it is affected by the climate change or any human influences, okay? And also it is also a Hong Kong record, and registered by the China-Hong Kong Monitoring Union. And also at the bottom you can see that we are closely collaborating with 2 universities. In Chinese university, we collaborate with the Geography and Resource Management Department. And also in Hong Kong University, we focus we collaborate with the Swire Institute of Marine Science under the Marine Biology faculty. And then the professors are also heavily engaged in our research, okay? And it is done early this year, 2021. So this is our first time, okay? And of course, we are going to bring students out to the field. However, as you know, because of the COVID, we cannot do that by the government regulation, but we have to do it virtually. But in the virtual environment, how can we engage students to keep them busy, keep them thinking, keep them working? That is another very interesting topic, okay? So it's a virtual field trip, but they're heavily engaged, okay? And also, we collaborate with these two universities, mainly because you can see that on the northeast corner, it is the Hoi Ha one, and it is a marine park, okay? And that means people can do some leisure things, okay? Kayaking, swimming, scuba diving, but it's totally protected, okay? And in fact, it is one of the professors, Professor Marava, who was also my classmate when I did the Master of Philosophy with him. And then he's now a full professor and helps the government to develop that area. And in the southeast corner is the Cap Doria, and Cap Doria is a marine reserve. And that means that area is totally protected, okay? And there is a science center there, is owned by the Hong Kong University. So that's why, we collaborate with them. And in the northwest corner, that is Jinbeizhou, that is the very, very famous oyster farm. In fact, in the diagram, you can also find out that a couple of years ago, the Yakutian students also went there for, for some fun time. And then in the south west corner, Phan Lao, Phan Lao Gok is a navigation route to mainland China. It's very busy indeed. Okay, so these four marine ecosystems are very, very different. So that's why if our students can get into the field to understand the water quality, to understand the ecology there, and then they have got a very good picture. And then if we can do it year by year, and then if we have got enough data, and then we can find out the trend. So that is the whole idea about this project. And of course, in this project, and then, as I mentioned, it was done early this year, is from February to March. And you can see that in the morning, they have got the morning half day school by law. And because of the COVID, they cannot have lunch together. So that's why in the afternoon is their free time. So we make good use of the afternoon for the virtual field trip. So on the 5th of February, we went for the first one. And then we invite Professor Wajan to give us the lecture, to understand the second point of our field trip. And then I also taught a bit, during the class in the morning, right? So we have got all this. And also after all the field trips, and we invited Professor Marava from Chinese University to give us a lecture, to talk about how ecology and climate change are related, okay? So this is the whole process of our study. And so their lectures are also very, very inspiring. Now, before we move on to watch a video, and then I would like to introduce how it works in a field trip, because we need to bring students out, okay, so that they can have the real experience. This is very important. But in the Zoom, okay, how they can learn. So that's why we have to design that with the professors very, very carefully. Now, at each field trip, they have to do a lot of things. First of all, before the trip, they have to make some prediction. They have to search, the background information about the area. And also, when we did the FIP trip, we have got 360 photos for them as well. And there are many websites that they can get into to understand the information about that particular area. And also, they have to do some prediction or hypothesis, especially for 4 parameters, because it is also within their syllabus of the exam. Water temperature, the pH, the dissolved oxygen, and the solidity. And also they have to understand the correlation among these four. And then they have to do some prediction. And then after they have done the prediction, and then, we comment on them, and then, we get into the field. And then of course, the students were in the Zoom, okay? But they are very busy, okay? So we have got the real-time observation, okay? I'll give them some briefing, some description about the place, and then they have to decide in that particular site where we are going to measure, okay? They have to select two particular sampling points with specific criteria, such as accessibility, make sure that they are representative enough about that particular area, and also the two checkpoints must be 50 meters apart from each other, at least, something like that. And then after they have got discussion, and then they come back, and then we make agreement on the 2 points. And then we teachers, okay, in the field, follow their wish and get into that particular checkpoint, and then to measure the 4 parameters, okay? Because of the time, we can measure 5 times. Now, if they really go into the field, in the past, they usually did 20 times, okay? So that the more data, the more reliable the data would be. But here, 5 times, okay? So after we finish one, and then, we collect some water sample for the lab work, and then we go to another checkpoint, and then to do the same thing again. And afterwards, and because we have got the real-time broadcasting, so that's why they have to mark down the data, they have to calculate the mean, they have to do all the things at the same time. And then we have got 4 rounds of presentation. And then first of all, they have to compare the actual data with their predictions, right, to see any discrepancy, and then they have to discuss, they have to present. When we teachers are in the field, and then we are in the Zoom together, okay, because the Wi-Fi is so good in Hong Kong. And secondly, after they have got their presentation, understand that because 70 students are divided into 4 groups, so that's why they have got a group presentation. And then the second round of discussion would be the differences between the water sampling points, because there are 2 water sampling points. So there should be some discrepancy they need to understand. And then they have got 10 minutes discussion, and then they have got a couple of minutes presentation. It's another 15 minutes. And then because they have got that set of data, and then they can compare with the data of that particular site with another site, especially for the second field trip, they can compare the first one and the second one. And in the third field trip, and then they can compare the first, the second, and the third one. Okay, so to find out the differences, because there are 4 different marine ecosystem. And lastly, they have to encapsulate the most important element of the factors, because they are doing environmental impact assessment. They have to outline the critical factors that affect the water quality, okay? And after the field work, there's the lab work as well, okay? So there's the fun time together. Okay, now, I would like to show a video to visualize, how it works. And I would like to show a video.
Rajan from University of Hong Kong. And I work here in the University of Hong Kong for almost 20 years and study about marine environment, and particularly about life in the marine environment and the coastal areas.
Actually looking at other things as well. You know, water cannot be, you know, an independent parameter in any particular area. So with this understanding, I will move on and try to explain a little.
So I hope you have got some understanding about the field trip, and also the data has been shared in a conference in Chinese University and also presented in their master degree program. Okay, now let me get back to the PowerPoint and then for some illustrations so that you can have a better picture about how it works. Okay, now remember, we have gone to 4 different places, and of course, in each of the places, we have got the abiotic factors like the tide, the air temperature, the wind speed, and atmospheric conditions, and also the observation of the local habitat and the observation of the water quality. And also, after we have collected the samples, and then we have got some lab work, especially, we collaborate with a laboratory to understand the heavy metal concentration, because it is also it also reflects the human activities as well. Okay, and so for example, the first one, so it's the northwest corner. Jinbeizhou is an oyster with habitat, okay, and it's our first site because it's so close to our school, and it's a very, very famous for oyster. It has a history of 700 years, and it's a heritage indeed. And in fact, our students also went there before, and also the students from Yakutsk also went there when they visit Hong Kong, and then we got into the boat, get into the sea to open some fresh oyster. Right. So as I mentioned, it has a history of 700 years, and also there are many, many oysters because we have 10,000 rafts. And in each raft, there are 10,000 oysters. So 10,000 times 10,000, that means in the sea, there are 100 million oysters. Okay, so there is a very rich resources we need to protect. Okay, it has a very, very, valuable in economic and cultural values. And on the right, you can see the student, David, is from Yakutsk. Okay, and also in the right bottom corner is the students from Yakutsk also going there a couple of years ago. So going back to our study, and then we have got two track points. One is the oyster disposal area, another is near the mangrove. And you can see that when we are measuring and then through the real-time broadcasting, students are working together and do the calculation, and also in the breakout room they need to discuss about the prediction and the actual data and understand all the parameters. Okay, so basically this is the summary of the data, and you can see that it's pretty okay, especially when we are talking about the dissolved oxygen. That is our key concern. In Hong Kong, the standard, the benchmark is 4. That means if it is below 4 milligram per liter, that means we are lack of oxygen in water. And 7.33 superficially is okay, but if we think it more critically, because this area is the fresh water meeting the salt, the seawater, in the solidity is only 20. That means it should have a greater capacity compared with the ocean to carry more oxygen. So that's why 7.33 over the benchmark, but because of the capacity, we are not that happy about that. Okay, so that's why in the observation, the water is a bit turbid, and also we can also find a little bit oil in the mangrove area. And we need a lot of conservation, and especially, we have got a purification system in place. And also, I also help an NGO called the Nature Conservancy to bid 200 million euros for this area. Okay, sorry, 20 million euros. Okay, so that's why Hong Kong University operate a lab there, and also we also visited there before. With the Yakutsk students, and so we make use of the iron water to purify the oyster so that it is eatable. Okay, we did try some oyster together. It's very, very yummy. Okay, so the second place is the Cap Doria, is in the southeast. It's a marine reserve. That means all human activities are not allowed. It's totally protected. The only thing can be done is the research center run by Hong Kong University. Okay, it's a sponsor. The sponsor is the Swire Group. It's a British firm, so that's why it's called Swire Institute of Marine Science. Okay, so it is a highly protected area with great biodiversity. So that's why I went there during the low tide to take some pictures. Okay, you can see how wonderful the marine organism there. You can see sea cucumber, chiton, yuchin, very yummy, and also different kinds of seaweed. Okay, it's a very lovely place. Okay, and also barnacle, very yummy. Okay, as well, and also they have got some plants. Okay. Near the area, and this is the general pictures about the place, and then you can see that the pH is okay, the solidity is natural 30, and then the soft oxygen is much higher than the first one, 9.2. Okay, so that means the water quality is very good. Okay, so how about the third one? It's the third one is Hoi Ha Wan. Hoi Ha Wan is a marine park. That means it is something like a marine reserve, but some activities are allowed, like swimming, kayaking, or windsurfing, or some kind of diving. Okay, of course, it's limited amount of people are allowed to get in, but still get some freedom to make some fun. So it's a marine park, okay? And this is the area around. You can find a lot of corals and a lot of, starfish, fish, and a lot of organisms. The biodiversity is also very nice. Okay, that is what we found in the field trip. Okay, the crab, okay, the chiton, the sea cucumber, and different kind of crabs as well. Okay, so this is the general picture, and you can find out the data. Okay, the students make some summary calculation and conclude that it is pretty okay. Okay, and in terms of the solidity 25, the dissolved oxygen is 8.29. Okay, slightly better than the first one. Okay, the oyster farm, but worse than the second one, the marine reserve, because of some human activities. So that's why the quality is a bit lower. Okay, and then the last bit is the Phan Lao Kok is an open area. It's a navigation route towards China. Okay, and Phan means boundary. Lao means current. That means you can find a clear boundary about the current. In the picture, you can see that it is the meeting point where the muddy fresh water from Pearl River meets the seawater from the Pacific Ocean. So that's why the boundary is so clear. You can find it nicely. Okay, and it's a very, very rough area. So that's why I have to do some safety precaution to get down to explore, and we can find a lot of barnacle there. Barnacle is a kind of organism living in clean waters, and it's eatable. It's very expensive. Okay, if you go to Barcelona, and then they have got quite a lot. Okay, in Hong Kong, we can find this occasionally in market. Okay, so the water quality, again, 7.77, by the number is lower than others. And also we take solidity into consideration. Remember, fresh water should carry more dissolved oxygen, but they can only get 7.77, so that means it is not very ideal, and also the pH is slightly lower, so that's why it draws our attention whether any ocean acidification happens there or not. But of course, it's our first snapshot. We have to do it year by year, and also there are several variation, like seasonal variation, like the time of the tide. Okay, but we try to make it equal. We have all 4 field trips in high tide. Okay, so that's why we have to some controlled parameters. But of course, if we can go there every season, during the summer, during the winter, it will be much better. But because of the time and also the arrangement with the students and also the university, we decide to do that every year. So that means every February we'll do this. Okay, and then we'll accumulate a number of years to see the trend. Okay, and we have got evaluation, and also we collaborate with the Chinese university to have the students' work, the students' focus group, the evaluation, and also the teachers' interview. And we have got different sources to understand how good our program is, and we will make some adjustments, improvement next year. Okay, so that is our study. I hope that I don't overrun, okay, and give you some understanding about what Hong Kong is doing on climate change and ecology. And we focus on water, marine ecology, as a starting point. And also we are still in a very early stage. It's our first time, and we hope that next year, next year, 3 years later, and then we have got more and more data, and then we can make some comparison and see the trend. Okay, So thank you so much for this opportunity for me to share with you about this little research done by high school students with professors in 2 universities. Thank you so much.
Amazing. Thank you very much, Dr. Patrick Lam. Thank you. That was wonderful because it gives an incredibly interesting cross sections of all these activities that's happening in Hong Kong, especially with involving the several universities and school students, high school students on a topic which is extremely important for the people of Hong Kong and also for the local economy. And in fact, this is the place where so many people lives in, and also there is a high impact of the local population to the environment as such. And here, today, we're living in a place where very sparse population, which is a very characteristic of our land. And today, I have a pleasure of giving the floor to Professor Tрофим Максимов, who's actually been doing incredibly interesting work for so many years now on the impact of the local permafrost regions to the world climate, global climate. So thank you very much, Dr. Patrick Lam. So now we're giving the floor to Professor Tрофим Максимов. Thank you.
Thank you, Vasily. Thank you for inviting me. Good afternoon, everyone. What place is better? Over there? Time is not so limited. Yeah, it's good for me. Yeah. My name is Tрофим Максимов. I'm from Siberian branch from Russian Academy of Science. And also I am scientific supervisor and principal investigator of more than 50 international projects with 18 countries during 30 years. I would like to give my lecture about the role of permafrost ecosystem in global climate change. What kind of investigations were carried out in this very big territory of in northeastern of Russia with foreign scientists. And in the beginning, I would like to show this picture about the changing of climate during 71 years on global climate change. Red colors showing the increasing and blue is decreasing of air temperature in this side. Definitely, we are staying now in the period of global warming, and this phenomenon is more intensively growing in Arctic regions, in high latitude ecosystems. This figure shows from IPCC reports. This figure shows how to will be with temperature and air precipitation amount in the future in Arctic regions. And we are now every scientist is talking about the global warming. Very strong depends of seasons. This shows figure shows how to change of change temperature air in winter time. Nevertheless, the last the last 50 years, this phenomenon, not global warming, not so depends from seasons. In any seasons, in summer, in springtime, autumn time, and winter time, is increasing now. And when we carry out in this place investigations, the role of regional climate to global climate change, with from and influence of high latitude ecosystems for this climate change. due to how to change of water and energy exchange, and also how to change the greenhouse radioactive gases to the regional and global scales, and also how much of carbon and also some trace elements is delivered from our main rivers to Arctic oceans. According to these obtained results, more than 75% of emissions from greenhouse gases is gives to CO2, carbon dioxide, and more than 18% to methane, and also few amounts in contribution of another gases, for example, nitrogen oxides, and also gases from industrial origins, and also some freons and ozones, very strong impact to greenhouse effect for global warming. According last year's result, concentration of greenhouse gases very strong depends with increasing of high latitude. With increasing high latitude, of course, due to physical properties of these gases, is the concentration of greenhouses increasing. And we carry out in this place using some aircraft measurements from on the different heights of this land. We carry an aircraft in the way aircraft investigations. This figure shows our measurements in 6 profiles of the concentration of greenhouse gases, five kinds of greenhouses. This one includes CO2, methane, and nutrient, oxygen, and so on. Yeah, and also we found very strong year by year now increasing of CO2 greenhouse concentration in this land. Not only regional scales, also including global scales. Our height measurements levels is about 3 kilometers. This is how to say it's global scale. For example, for this using these measurements, we can estimate and make some upscaling measurements for big territory. For example, on the global scale. Yeah, this one also includes last year's experiments with CO2 gases, carbon oxygens, main greenhouses. Every year, 1 year's growing excrements about 1.2 ppm. Year by year, it's now we have trend with increasing of CO2. According global warming now is increasing also not only impact not only for air, for also for permafrost. This figure shows the increasing of permafrost in different countries in different periodical and climatical zone. This one include not only our republic and also including North America, in some Canada, and Asia, in many countries. And in the last 40 years, the size of permafrost area is decreased about 40%. It's very serious problems for climate, for us, for our populations. And with climate change also increasing the active layer, it's sowing and melting periods is very important for plants. is year by year is another increase in also active layer place. For example, in some place we can find in the central parts, some place non-frozen in winter time. It's very serious problems. Then we will carry out our investigation in main representative ecosystems. This figure shows the distribution of our species trees in Russia. Brown color means it is main dominant species is larix, large trees. It's more than 60% of our Russia is carried by large species. Second, red pine trees is more around 70% of this territory. And second, more representative biomes, which will be impact in will have big contribution to the global warming is tundra ecosystems. This figure shows the distribution of tundra sites in these regions. Also, we don't forget also about another ecosystem represented. This is forest tundra ecosystems. It's boundary and transition zone between tundra and forest. This territory is concentrates a lot of amount of carbon in the soil and in the permafrost and also in the plants. About 25% of carbon in Russia is concentrated in this place. It's very important. Also, this place is a very good place for sequestrations, for assimilations, for sinking of carbon, because we have green plants in this place. Basically, of course, large forest. And this figure shows our last data about air temperature trends, which I already told you, not so strong, depends from season. Any year you can find this impact, not only in winter time, like in which was introduced in IPCC reports. And also now it's changing also the period of freezing and thawing, and also in changing of growing seasons for the plants. Is year by now is increasing growing season for photosynthesis process. And second, also same entourage concerning of precipitation amount, also increasing year by year. And according to this increasing of precipitation amounts, we can find very huge floodings area in northeastern of Russia, in our land. This figure shows publication which was published in very peer-reviewed international journals and in Nature. It was about last 50 years, the size of water and lakes water is increasing 12 and 15%. And this flooding is a very strong impact also for life of our trees. Our trees died. And because too much water is very bad impact to the roots of root systems of plants, and all trees is died. And also we have very old mature trees. That trees is not so good sensitive and tolerance to the wet condition. Nevertheless, of course, this is water-like species of plants. These figures also some same phenomena on the right side of Lena River on the way to Churapcha. You can find this is impact of decreasing of precipitation amount and becoming these dry seasons now. And also, we don't forget about the impact of insects in this place, and also impact of forest fire in this place. Global warming also impact to some, so for the infrastructure of our villages, you can see some impact to our road and also for our villages. Now it's very difficult to some place to find good and reliable place for construction of new buildings. Every 7 to 10 years, you can change place from one side to it is very big problems for the local populations. And also some pictures about some landslides on the way to Amgari, which was in 213. This is some example of soil erosions in this place. More than 3 kilometers of roads was completely destroyed. Yeah, and it was big. It was a very big economical and financial expenditure for local government. Yeah. And also this figure shows some formation with global warming and formation of Allah's ecosystem in, with after forest fire, after cutting of plots, after cutting of trees, and after land use, beginning some process with formation of Allah's ecosystem, with low productivity of grasses in this land. And very difficult for facilities of local people in this place. They can find more better place for life. And this is some stages of formation of the thermocast processes on the right side of Lena River. Yeah, maybe you know, in opposite side, a lot of place, Allah's ecosystem place. And this changing of climate is global warming, also changing the number of species of plants and animals in this place. According our result during 70 years, the number of, for example, vesicular species, changed. For example, if in 1935 we found only 1,200 species, so now we found 1,800 species. More than 700 species, new species we found. It's very interesting. And also this one, for example, I would like to show all the main species which we can to find in the forest, because, for example, for investigation another small species, for Moses lesions or so on, very difficult, yeah, because very big territory, and our methods is not usable for clarify how much and estimate how much species we can find. And concerning of mammals, also, for example, during 70 years, we found more than 30 new species. 2 times is the number of mammals increasing here. Moving some species, places, southern plants moving to the north, and also trees, large trees also moving transgressed to the north, tree lines now changing. Yeah, it's a very interesting phenomena. And also you can find, for example, very good expansion of and transgressed of some shrubs in Arctic, in tundra side. Yeah, it's concerning of our result with forest fire. We prepared some speculative scheme for depend of type of forest fire, surface fire, and ground fire, underground fire, and another abnormal long fire. It depends of type of forest. We can find how to build with regeneration process in this place. In some place, very difficult for regenerations, but in some place possible. Concerning of large forests, now usually is occurred in large forests is surface fire. It's not so bad for this forest. And now is, for example, I already told you we have very mature forests, very old forests, more than 47% of 47% of our forest is mature forest. And this is very good fuel for forest fire. And after forest fire is emitted a lot of greenhouse gases into atmosphere. This figure shows how much of emitted carbon into atmosphere. It's, for example, in 1998 was one of the strongest fire in Russia. Same in these periods. In that period was emitted a lot of greenhouse gases. Now we're living the period of decarbonizations of countries. We must be ready to carbon tax. Will be the period for sailing and delivering of carbon. Any country will be very strong delivering sailing periods for between countries. Yeah. And I'm afraid, for example, after this year's fire, we will pay big amount of money for European Union. Yeah, it's definitely our land is sink of carbon, but we have now big expenditure with forest fire. We emitted a big amount of greenhouse gases into atmosphere. Yeah, I already told some species is moving to the north. This figure shows some species they have special C4 pathway photosynthesis. They're moving to the north. This is one of the pioneer species for this land. This shows some what kind of a species is moving to the north. This one including that species, C4 pathway photosynthesis species. And also now some new species we found in our place. For example, during my investigation in Spasskaya Pat experimental forest station near Yakutsk, this is located in the north of our city, 30 kilometers far, and we found new species, Rhizopogon laricinum. This is Cornelius listvenичный. Nevertheless, it's very interesting. That mushroom has master pine trees, but now changed to large. It's very interesting. In new species we found, we use some special biological methods with Japanese. And also new insects coming. It also, this is, for example, zinc-bound encephalid. Yeah, we found also in our experimental stations in central Yakutia, very close from city now. And after global warming and year by year is increasing the hotspots, extinctions in the world. This was include not only Siberian tundra, some species also disappear in this place, and some species is growing and expand in this place. But also this one includes also some northern part of America and northern Canada and so on. And we are made some scheme about how to global warming to impact for vegetations. For example, this is from secular, how to, for example, in high latitude ecosystem warming is very strong impact for increasing of shrubs in tundra site, for example, and very strong impact for changing of permafrost soil. Permafrost is melting. And also after melting is emitted a lot of hazardous gases. This one beginning some bad process in change to high latitude ecosystem warming. And also increasing of shrubs, very strong increasing to very strong impact to decreasing of albedo. And also for very strong info for increasing net radiations. And also to very strong impact for atmospheric heating, global warming, yeah? And after that, again, return to beginning of early melting periods and so on. And we were starting our, we began our field work with in international projects on global warming in 1991 first, together with University of Hokkaido and also Forest and Forestry Products Institute from Sapporo for investigation of impact of changing of climate to atmosphere, biosphere, hydrosphere, and lithosphere of these regions. At first, we began our field work on this territory. It was very serious. We had big expenditure. We lost a lot of amount of money for 5 years. After that, we decided to starting new monitoring studies in our scientific stations. And then we established several experimental sites in these regions. This figure shows our experimental site in central Yakutia, in southern part of Yakutia, in moderate productivity and large productivity of large forests. And also we established station also in tundra site. Now, and also finally, we established 4 stations in forest tundra ecosystems. Now we one of the leader. Now this works network we are calling Saha FluxNet. Flux measurement of energy, heat, flux measurement of water, and flux measurement of the carbon flux. This one including CO, carbon dioxide and methane. Yeah, meaning flux, Saha flux network. And now we are one of the leader. I told you not only for that's all. What happened? No? We are leader not only in this number of amount of experimental site station in this place, but also including our with our instrumentary base. We have a lot of devices and equipments for investigations, and also this one also included the number of measurement values. What kind of a lot of scientific parameters we are investigated. And then the main purpose of this experimental station is to carry out interdisciplinarity scientific research to address fundamental issues that reveal to the complete real picture of the status of environment, the nature of the interaction of the all parts of, for example, atmosphere, biosphere, hydrosphere, and cryosphere. One station is working like small institutes. We have very big projects, very big corporations, and very high complex and multidisciplinary study in each stations. We are using 4M methodology for our research on climate change, on local, regional, and global scales. For example, 1M is monitoring. We will carry out investigations on flux measurements and climate measurements using satellites, using aircraft, using flux tower, big tall towers, and also using terrestrial surface investigations. 2M, this is manipulation, some experiments with possibility global warming scenarios, including a forest fire, surface forest fire, dominated forest fire, and also with changing of precipitations amount. And also using our many unique and very big data set. We are using some mathematical models for predictions how will be with our ecosystems, representative ecosystems in northeastern of Russia in the future. And then finally, of course, for M, this is some management. We would like to combine our scientific knowledge with society and also with stakeholders, including some policy makers or so on. In this place, we will carry, this is a location of our stations. This some I would like to show this our horizontal experiments from from south to the north. Distance about the length of distance about 1,100 kilometers, and included representative permafrost ecosystem, large, high productivity large forest algae station in Usmaya, Spasskaya Patch station in moderate productivity of forest in central Yakutia, and also forest tundra station and tundra stations. This is some horizontal. It's very big area. And also, in this place, we carry out investigation using some satellite measurements. We are using remote sensing measurements and also terrestrial surface measurements for estimation of vegetation type for each biomes. which is very important for upscaling our obtained result, for example, on greenhouse gases, on carbon, on nitrogen, and so on. Then also we are carrying out investigation in the laboratory. We cultivated our Yakutian trees in the laboratory, and we are measure some physiological biochemical processes, how it will be with photosynthesis and with respiration of plants in the future, how will be in the future with productivity of forests. And also we have some surface terrestrial observation, field work near tower site, very big tall tower site, for investigation and for estimation for all components of carbon and nitrogen in ecosystems, including air, including air, including vegetation levels, including soil levels, and also permafrost. And also, of course, also we're using some mathematical models. After using this one, this is very important for scaling and for estimation and for the focus of carbon budget and nitrogen budget for these regions. About our vertical investigation, I already told about horizontal, more than 1,000 kilometers. But then also we have some profile measurement from space to permafrost for lithosphere, lithosphere. We are using some satellites, NASA Aqua satellites, and also Japanese JAXA satellites for our investigations. Then we are using some aerovisual. We are using aircraft, for example, Il-18 and 2 drones, yes, aircraft and so on. This aerostat in this place. We have also some land surface measurements. This is including some big tower. We have tower site. This is our tower. It's with height 33 meters height. Near Yakutsk in Spasskaya Past, for example, we have 6 tower sites. And also we study land, including soil and permafrost. We are calling this is investigations of Sahara Flux Network. Yeah, this is our main station, which was established 70 years ago. This is one of the first Russian experimental forests. In this station, we have 70 years inventory data about productivity of this forest. Depends of vegetation type and depends of tree species. It's good for modeling and also for investigation. We can find very reliable and exclusive place for installation of our flux towers for the measurements. And from 1991, we began our flux measurements with Japanese, then with European Union in this place. And second station was established in 2003 in Tundra with Dutch scientists from Netherlands. We have some mast, not tower site, but of course, height of vegetation is not so wide. We don't use big tower site. It's only 6 meters tower is enough for this place, for excellent footprints for upscaling. Together with Dutch scientists, yeah. This place for crane, yeah, Catholic site. And so first such station, Elgai station, not Suntar. This is in Usmaya regions, yes, another one. Yeah, it's Eventian name, yeah. Eventian, yeah. Event name, this means center of land. Yeah, LGA, yeah. We also established with Japanese in this site, very high productivity of forest, very beautiful place. And also, finally, we established also with Japanese in one station in forest tundra site, yeah, from 2011. Now we have very excellent, very good, good experimental site with good maintenance. Yeah, with high amount of money, of course. We are supported with not from Russia. We have international projects. Yeah, and these are our measurements on plant levels for study of photosynthesis process. Yeah, carbon dioxide uptake, and also some respirations measurements. We are carrying out field work not only here in Russia, also we carry out in our investigation in US, in Canada, and so on. It depends of our grants. And also we are measure some soil respiration, how much of carbon dioxide and methane is emitted from soils. It's also very interesting problems. And also we are carry out some very high quality instrumentation for AD covariance measurements on the top of our towers. The frequency of measurements are very high accuracy methods. 20 gears, it means 10 measurements 1 second per 1 second. Yeah, very high quality. It's very good for giving some mean value, 10 value or something. We can change 20 gears or some possible, yeah. And we are studying all components of carbons, for example, not only including this method includes also some process with evaporation, emission by plants, monoterpenes, or some substance is emitted also from trees. And also with changing of climate, this amount of carbon is increasing. And this figure shows that our regional scales of our measurements in central part of Yakutia. This is the left side of Lena River, and right side in opposite side. We have tower sites in both sides on the two banks of Lena River. For these measurements, we are using, this is our tower site. On the left side, we have 6 towers in this bank. In opposite side, 2 towers. And we're using some radio zone, also using some balloons, observation balloons, and using aircraft. We are upscaling these regions. We estimated on the scale 200, 400 kilometers by 200 kilometers. We estimated how much the changing of carbon greenhouses balance in this place. And now we found not so big difference. And in some tower from opposite side was removed, remained from this place. And this is our tower site, near tower site. We have very good instrumentations. More than we have in one place near tower site, we have more than 300 sensors. Temperature, minimum temperature, soil moisture, solar radiation, etc. Blah, blah, blah. Too much, yeah. Yes, and all data is from all sensors is coming to one box for data logger, and after that we're using our computer. we are trying to proceed our result. After that, we can change with our data with foreign scientists. And we are carrying out investigation not only in terrestrial parts of our republic, we will carry out our investigation also on the river, hydrologic, for estimation of hydrological flux. This figure shows our Lena River catchment experiments for estimation of how much of carbon and trace elements is delivered from Lena River and from main tributaries from Aldan and Vilu River to Arctic oceans. And this is a result from our aircraft measurements, and also finally using our many 20-year time series experiments in central part of our republic in the forest, and also our 14-year time series experiments in tundra side. We estimated how much of carbon is sequestrated in this place. This figure shows the interannual variation in central parts. We can find very high interannual variability in this place in central Yakutia, in the large forest. Depends of how to change climate parameters here, because interannual variability climatic also very high. Of course, and also uptake of carbon in central part, in central Yakutia is very high. Nevertheless, in southern part of Yakutia, in high productivity of forest, not so store interannual variability, same like in tundra side. This is very strong, depends, of course, in the case of tundra with marine climate. In the case of in southern part of our republic, high productivity of forest with mountain climate. And we estimated how much, I already told, our forests uptake sink of carbon, sink, yeah. And you can find many years mean value for tundra side and also for central Yakutia high moderate productivity of forest, and also high productivity of forest. And we make some speculative scheme which shows how much of all components of carbon is contributed to global carbon cycles. This one including trees, vegetation, including also soils, and so contribution of permafrost and so on. And also same result we obtained concerning of water, how much water is evaporated from this place, from each part of ecosystem with components of biomes. And also we make some results about how much of carbon is delivered from Lena River to Arctic oceans. Yeah, for example, from upper layer, it's more than 46% is delivered to Arctic oceans. And from this value, from 100% is 68% is delivered from Aldan River. This is why, and 10% is delivered from Vilu River. Why is this value is higher than in Vilu? Because this place is have another vegetation type, high productivity of trees, and also different geological structure. And about what will be in the future with our ecosystem, with our forests and also tundra. We made some extra explanation of our results, using our many years results. And now we can say it is some ideas, some hypotheses. Probably now is the period for decreasing of carbon sequestration sink in the forest. I already told we have mature forest. Mature forest is uptake not so much carbon than more young trees. And also very strong impact of global warming. Permafrost is melting and concentration a big amount of water, and some trees is died. Some trees is remain from biosphere cycles. Nevertheless, in tundra side, now is the period for increasing uptake. What is the reason? Now we can find some very big and very strong expansion of shrubs in this place. And this species, trees, they have very high sequestration, high photosynthesis during long light periods. Yeah, and then about our result, we were obtained in the laboratory. I already told we cultivated our Yakutian and Japanese trees in climatic conditions, in the according scenarios, climatic scenarios, in condition of doubling CO2 concentration in plus 4 degrees centigrade. According to this result, we found very interesting result. The efficiency of water use and nitrogen use will be increased. It means it will be some process with activity of microorganisms. Of course, it's very good positive reactions, will be very good positive reaction for photosynthesis and for the growth of plants and for accumulation of carbon. And also will be, it will be very strong decomposition rate with formation of main elements like nitrogens. It will be very good for this process, for the productivity of our forest. Nevertheless, we have another phenomena is some process with perturbations. This mixing of plants, soils. If this will be accelerate this process, nitrogens and another big organs will be out of these cycles. In this process, if there will be this process, the photosynthesis rate and growth and carbon accumulation will be less. It's too bad. This is also one of the hypotheses. And using our many years results with within our European Union projects with 80 countries in Russia, we estimated how much of carbon is sequestrated in this plate. We estimated carbon budget for Russia. This is one. This experiment include main biomes: forest, grassland, tundra, wetland, and other. We use some many classification maps. Very difficult to use for forest classification map with 12% accuracy, and we using some 3 mathematical models: land ecosystem applied method and also some inversion method using dynamic global vegetation models, and also our direct measurements using our tower. We estimated how much of carbon is sequestrated in this place in Russia for including 5 biomes. According to these results, this is how much of carbon is sequestrated in this place. Yes, for example, more than 1 billion tons of carbon every year is accumulated in this forest. It's very big. But, for example, if we will use our expenditure with forest fire now, and also including some impact with insect, and also with problems with land use, and also with using some forest products, for example, for logging or some cutting of forest. Net bioproductivity will be decreased. Yeah, this value, for example. Now it's preliminary. It's experiment. Approximately 7 million carbon is sequestrated per year in Russia. This is very big value. In Kyoto Protocol, our Russia was prepared very small amount of sequestration. This value was only 160 million. This is 7. This is completely different. But if we will use another expenditures, for example, using how to much of water and lateral flux will be impact to carbon budgets, and how much of carbon will be used from forests, and how much of will be used this forest for fuel. We can find very small amount. Its amount is totally 200 million carbon per year. This is one of the, how to say, more in current time, these publications, our publication, one of the more reliable obtained result together with foreign scientists. Our investigations with international levels is very important, because we can, for the sailing of carbon between countries, we can prepare our data which we obtained using our international projects, not Russians. We're using some new methodologies for our studies. Thank you very much.
Thank you very much, Professor. Yes, there's one question, you see.
Yeah.
Well, thank you very much for the comprehensive scientific analysis and the statistics. So the fire do harm sufficiently the quality of the natural resources, and or even destroy them inevitably. So you reckon, what is the biggest task, not for the establishment or the political leaders, but for the society, to prevent the possibility of the mass extinction or the catastrophe in the nearest future?
You mean about forest or some?
Yes.
Huh?
All of the problems in the nearest future that we will have to face. What is the biggest task for the society right now?
Yeah, okay. Yes, it's a good questions, but of course, in the future, of course, I already told you this, the period of decarbonizations, we lost big money because we had big forest fire. in this case, we was thinking about how to manage our forests using not only international experience, also using some Soviet experience. We must try to cultivate and expand our forests. We must put big amount of money for conservation of forests. And also we were thinking about land use. Yes, it is also big problems. For example, for our republic, for example, in opposite side of our republic, in central parts, a lot of Allah's ecosystem with high productivity. It's not, it is without water. It is big problems. And we must thinking about also our management in agriculture. Nevertheless, with global warming, probably we expect an increasing of northern agriculture in this place. Yeah, agriculture will be moved to the north. Yeah, and also what? And also for using and for our data, for example, our scientific data, we must be very close to society. We must find joint work, then expand our and explain our work to stakeholders and policy makers. And they must thinking about our laws. Maybe better to change some laws. It's a big problem. Yeah.
Thank you.
Yeah.
Thank you very much for this fantastic overview of what's going on in Republic of Sakha-Yakutia. And I have a rather practical question. How soon Yakutsk as a city will collapse under this melting problem of permafrost? And what's the probability in coming decades?
Yeah, very, very difficult for say. But nevertheless, I will try. Yeah, yes. I'm afraid it will be. We need long periods, of course. Problem, if will be too much water, this process will be very fast, like very quickly. It will be changed, urbanization, ecosystem. Yeah, but very difficult to predict. Yeah. But you can find now some buildings which was destroyed, some basements, some destroyed completely. And also you can find many, many buildings in opposite side. Because in opposite side, too much capacity of permafrost. And it now is melting. And all big depressions became, for example, also some place, some field for aircraft measurement, some airport is completely destroyed in opposite side. You can find small lakes.
Thank you very much.
Mm-hmm. But this process will be year by year increase. Mm.
So this is the quite inevitable.
Yeah, yeah.
Quite inevitable trend.
Yeah.
Okay. Yeah. So we have more water.
Yeah.
After the forest, there will be more water, more lakes.
Yeah, sure.
Okay.
Yeah.
So that's what we understand.
Yeah.
And thank you very much. It was an absolutely wonderful presentation.
Oh, thank you.
Your research is extremely high tech, very sophisticated, hundreds of sensors, many people working in many different countries in a big network of researchers.
Yeah.
And this is a truly international global research and is a very high quality research, which has been doing, your team have been doing it for many years with your colleagues from Japan, United States, European Union, all other countries, Netherlands, and many other countries, which is absolutely wonderful, because this is the example what the science can do and what the people of Yakutia can do as a scientist. So thank you very much, and very much hope that our young researchers will join your team
sure.
and start to do some wonderful research.
Few words. Within our international projects, we have some bachelor and master course programs, syllabus. We have international magister course with Hokkaido University, and also we have some more than 12 years experience for holding our summer and winter schools on climate change. Every year we invited students, but not limited in the age. We are invited to our stations. They are walking, they are carry out investigations in our state, and also they prepared reports for us. It's really good, very good for young generations, for consist of new projects between our Russia. And of course, we need some education program with school children. It's also very important. We must start our studies. We must find relative children for the science. And we must start from maybe from kindergarten or from school. And we will receive very positive results. We are waiting for your good cooperation in this field.
Thank you very much. So the Yes, Professor Maximov, thank you very much. It's absolutely wonderful. And the Sakha Junior Science Academy obviously will have many more interesting projects. And with the help of Professor Maximov, I think we're going to have a very interesting courses as well as the master classes, etc. So please do watch our sites and also the LK14, our special platform for you. So join us, and there will be lots of more fascinating and interesting experiences waiting for you ahead of your time at your schools, etc. Thank you very much. Thank you very much.